Hello everyone, Mr. McDonald here. I just want to take a moment to talk you through how home learning is going to be in the next 3 weeks between now and the Easter holidays. Teachers have been challenged to provide live classroom lessons to reduce numbers of pupils, provide online materials for those learning from home, provide availability for working in the hub to make sure the children of key workers are supported, and to cover any staff illnesses that may occur between now and the Easter holidays. That's a big task, and the only way I could think of effectively covering all those duties was to create these online YouTube lessons. These lessons will talk you through what you need to know to complete the lesson tasks and hopefully provide you with about 2 hours of working materials that you can cover to make sure that you continue to develop through your maths. I will be hopefully providing online chat to support and guide you through these materials as well. But as I say, there's lots of different things that I could be pulled away to provide support with. So that may not always happen. I'm hoping that it will, and I'm hoping that our lessons will progress pretty much as they have been before. But if I am pulled away for any reason, you still have these online lessons that you can work through and make sure that you're progressing in your maths, because that is the most important thing during this period. Thanks very much for your patience, everybody. And without further ado, let's get into today's lesson. Okay, third years, your first activity is on the board. This is your starter. You have to find the area of the sector on the left and the arc length for that sector as well. On the right hand side, you've got a different type of question. You're trying to find the angle at the center of the sector. When you are ready to receive the answers, make sure that you move this video on, but for now you should pause the video and then complete this starter activity. Okay folks, going through the answers of the starter question. For the first question here, because I'm looking for arc length and sector area, I'm going to be using both of the formulas we've been working with over the last few lessons. So arc length, remember, is equal to the angle at the center of our sector divided by 360 and then multiplied by pi times the diameter. Okay, in this case, the angle at the center of our sector is going to be a large reflex angle that goes all the way around our sector and just leaves out 38 degrees of the 360 degrees that is in a circle. Okay, so if I take 38 away from 360, I'm left with 322. So I'm going to write 322 divided by the full 360 degrees in a circle times by pi, and then times by the diameter, which is 36 millimeters in this case. Okay, finishing that off, I'm going to grab my calculator. 322 divided by 360 times by pi and times by 36. That gives me a final answer of 101.16 millimeters. 101.16 millimeters. Okay, for the second part of this question, I'm trying to find the sector area. So again, using the sector area formula, very similar to the arc length formula, I'm using the angle at the center divided by 360. This time I'm multiplying not by pi d but by pi r squared. Okay, filling in the details that I know, my sector area is going to be 322 on the top of the fraction divided by 360. It's the same angle as before, nothing's changed. I'm multiplying that by pi and multiplying that by half of 36, which is 18 squared. Remember, the radius is half the length of the diameter, so if the diameter is 36, the radius is half of that, which is 18. Finally, finishing this off, I'm just going to type into the calculator again, 322 divided by 360 times by pi times by 18 squared. And my final answer for this is 910.43 millimeters. And then this time, because it's an area, I have to put a squared sign at the top of my units as well to show that I'm measuring squared units, squared space, two-dimensional space. Okay, if you need any time with this to mark your work, then make sure you press the pause button here, but I'm going to scroll down the page to do the next question. Okay, in this question we were given the radius length, we were given the area of the sector. What we were looking to find is the angle at the center here, x. Okay, so for this, because I'm using area in my blue box here, I'm going to write down the sector area formula again. So x over 360 pi r squared. My next step is I'm going to take the information from the diagram and fill in everything I know. So I probably shouldn't be writing sector area again because I know what the sector area is. My sector area is 167.5. My angle is unknown, so I've left that in as x, and I'm multiplying by pi and multiplying by the radius squared, which is 16 squared. Now, if you've put this into the rearranged version of the formula already, that's absolutely fine. You should get the same answer at the end. Okay, I'm going to rearrange the formula here. So the first thing I'm going to do is I'm going to multiply both sides by 360. That's going to give me x multiplied by pi multiplied by 16 squared. On the left hand side, I've swapped sides for those terms, and then 167.5 times by 360 is equal to 60,300. 60300. Okay, the next thing I'm going to do is I'm going to divide by the multipliers, so I'm going to divide by pi, and I'm going to divide by 16 squared. Same with this side here, I'm going to divide 60,300 by each of these things as well. Oops. There we go. Right, and that will give me my final answer of x equals, and then let's put this in the calculator, 60,300 divided by pi, divided by 16, divided by 16 again, and you get a final answer of 74.98 degrees. Okay, those are your starter questions. Hopefully you did well with those. If not, make sure you ask advice in the chat as long as I'm available. and if not, then make sure that you send me a wee email and I'll get back to you as quickly as I can. Alright, okay, so today's learning intentions. Today's lesson is about being able to use Pythagoras Theorem to find missing sides of right angle triangles. We're going to understand the definition of square numbers and square roots as well. You should be able to say at the end of this lesson, I can apply Pythagoras Theorem to find missing sides of right angle triangles, and I can square and square root numbers effectively. Okay, so quickly, a definition of a square number is the product of a whole number multiplied by itself. That's technically not true because you can multiply decimal numbers by themselves and those are decimal numbers squared. But for the purposes of this, a square number is a number multiplied by itself. The whole number square numbers from 1 to 100 are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, you get those by multiplying the numbers from 1 to 10 by themselves. Square roots are similar. The square root of a number is the number that multiplies by itself to make the original number. Okay, so 1 times 1 is 1, therefore the square root of 1 is 1. 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9, so the square root of 9 is 3. 4 times 4 is 16, so the square root of 16 is 4. And 5 times 5 is 25, so the square root of 25 is 5. Okay, the square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. So these terms shouldn't mean anything new to you. You have studied square roots and squares in first and second year as well. So what I want to do is just take a wee moment to resharpen your skills on these fundamental terms. What you need to do is you need to go to Quizlet. If you have the app, you can go to the app. If you just want to Google Quizlet.com, then you can go there as well. Go to the search bar, which is at the top right of your screen. Search McDon4LD, which is my username on Quizlet. Find the set called Powers and Roots. Click on the match game, and then match the terms by either clicking. If you are on an iPad, you should be able to click 2 terms that match, or dragging pairs from one to the other if you're on a computer. Who can get the class's fastest time? Going to give you 5 minutes to work on that, maybe 10 minutes if you really get into it, and then you should restart this lesson again. So pause this lesson, follow these instructions, and let's see who can be the class's fastest square and square root calculator. Okay, now that you've completed that exercise, we're going to move on. Right, Pythagoras theorem you might have heard before states that the sum of the squares of the smaller sides or legs of a right angled triangle are equal to the square of the hypotenuse. Now that shouldn't mean anything to you, but there are a few terms that we can take from this. The hypotenuse is a fancy name for the longest side in a right angled triangle. The hypotenuse is always located opposite the right angle. Okay, so if you look at the little corner edge of the right angle and follow it across the triangle, then it points to the hypotenuse side, the longest side in the right angle triangle. The other 2 sides are called legs. That is not as important a piece of information, but something that is good to know nonetheless. Okay, so Pythagoras theorem states that c squared, the hypotenuse of the triangle, is equal to a squared plus b squared, the squares of either other side of the triangle, okay, or the 2 smaller sides of the triangle. Copy that down into your jotters. Make sure you pause the screen because I'm going to move on shortly. But once you've got that copied on, press unpause or play, and then we'll get on to the next part of the lesson. Okay, so here's a little diagram that shows you what I'm talking about here. So I've got a right angle triangle here. My right angle is here. Okay, and it's opposite the longest side, which is 5 units long. Right, if I square 5 units, you should know now that you've been practicing your squares, that we'll get 25 boxes. Okay, all those boxes dotted up, that's 25 boxes there. Alright, if I square the other two sides, I've got a side of 3, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I've got another side which is 4, so that's going to be 4, 8, 12, 16. Okay, now obviously normally when we do Pythagoras Theorem, we don't actually draw out the squares and count the boxes, okay? You know your square numbers, so you should be able to calculate these without drawing any diagrams. That being said, 16 boxes here. 9 boxes on this side of the triangle. And 25 boxes for the longest side. Okay, what's interesting about that is if we take those two smaller sides, 9, plus on the other smaller side, 16, if we add those together, we get 25, which is the longer side squared. And that's exactly what Pythagoras Theorem tells you works for all right angle triangles. Okay, if you take the two smaller sides and square them, add them up, and then square root, you get what the largest side is. Alright, so I'm going to do a few examples of that now. Okay, I've got two right angle triangles here, and I'm going to work through how to solve the longest side that's missing here using Pythagoras Theorem. Okay, so first of all, what I'm going to do is I'm going to write down my equation, which is c squared equals a squared plus b squared. The second thing I'm going to do, because I'm missing my hypotenuse, which is opposite the right angle of the triangle, my a and my b values are the two numbers that I have on the outside of the triangle. Okay, so I'm going to rewrite my hypotenuse as x squared, because that is the letter that's being used to hold the place of this value just now. Okay, a squared is going to become one of the other two sides. It doesn't really matter which one. Okay, and then b squared will be the other one. Okay, this would work exactly the same if I had chosen to put 5 first and 12 second. Using our squared facts, 12 squared, 12 times 12 is 144. Again, you can use your calculator for this if you need to. 5 squared, 5 times 5 is 25. Okay, so what I've done so far is I've substituted in the numbers that I have in my triangle, and I've squared each of them. 12 times 12 and 5 times 5 for each of these separately. Okay, the next thing I'm going to do is I'm going to add my square numbers together. So 144 add on 25 gives me 169. And then to finish this off, to find what x is, my missing side, I'm going to have to find the square root, because the opposite of squaring is square rooting. So if I have x squared, to find out x's length, I'm going to have to undo that squared by square rooting. Again, that's something we went over when we did changing the subject of a formula. Okay, so to finish this off, I'm going to do the square root of 169. Okay, my answer is 13. 13 times 13 makes 169. So my length of side x is 13 centimeters. Okay, just to recap that one more time, I've put my numbers in. 12 and 5 go in because they're the two smaller sides on this right angle triangle. I've squared them. I've added them up. I have square rooted my result, and that gives me my final value for x. Okay, if you need some time to copy that down, pause the video here. If not, I'm going to move on to the next question. Okay, so one more example here. I have got my formula to write down to start with. C squared equals a squared plus b squared. I know that my hypotenuse has been replaced with the value x just now. So I'm going to write in x squared is equal to, I'm going to put in 45 squared plus 28 squared. Again, if you wanted to do 28 squared first plus on 45 squared, that wouldn't be wrong either. These two smaller lengths are totally interchangeable. Okay, so using a calculator, 45 squared is equal to 2025 or 2025. And 28 squared, 28 times 28 is equal to 784. That means when I add my two values together, I'm going to get 2,809. Okay, I get that by adding my 2025 to my 784. Okay, so I now have the value, a single number for x squared. To finish this off, I want to find x on its own, so I'm going to square root the answer that I got. 2,809 square rooted it gives me a final answer of 53. So 53 centimeters. Now this doesn't always work out perfectly. I know the two examples we've done, we've got a whole number answer, but it sometimes can be a decimal, so don't be shocked if you get an answer that is a decimal number. Okay. Again, if you need to copy that down into your jotter, pause here. If not, we'll move on to the next part of this lesson. Alright, your next task is to complete two examples of your own. What I've done here is I've created a scaffold for you so that all you need to do is fill in the blanks at each step of the calculation. Okay, so for the first one, with 12 and 35 in your triangle, you want to insert 12 and 35 into your blanks like this. Then work them through just like I've showed you in the previous two examples. Okay, do that again for the right hand side question, and then I will give you the answers in a couple seconds. Make sure you pause the video here until you've completed both of these examples. Alright, okay, so the answers to each of these questions are that x was 37 for the purple triangle and that y was 45 for the green triangle. Very well done if you got to those. If not, make sure you're asking me questions or sending me a wee email if I'm not available in chat. Alright, now that you've done a few scaffolded questions, I've got 5 for you to try out here, all by yourself. Again, follow that same structure that I've showed you now to find the value for x in each different example here. I'm going to show you the answers in a couple of seconds, so make sure you pause the screen here and complete A, B, C, D, and E before you get your answers. Alright, okay, so the answers to the questions. Part A, you should have got an answer of 73 centimeters. For B, you should have 39 centimeters. For C, you should have 85 meters. For D, you should have 53 centimeters. And for E, you should have 29 meters. Well done if you got those. Again, if not, if you're not sure about why you didn't get those answers, make sure you're asking for support or guidance in chat or through email. Okay, so Pythagoras Theorem does not only allow us to find a missing largest side of a right-angled triangle. Okay, it's not just for hypotenuse. It is also for the two legs in the triangle as well. The way that we find the legs is we need to rearrange this equation to find either A or B as the subject, okay? Or A squared or B squared as the subject. So what I'm going to do is I'm going to take away B squared from this side of the equation, and I'll also take away B squared from this side of the equation. Alright, that'll leave me with A squared on its own is equal to C squared minus B squared. Okay, so the smallest side of the right angle triangle is equal to the hypotenuse squared minus the other smaller side squared. Alright, I'm just going to reveal at the bottom here that full equation. Make sure you take a note of that in your jotter, and then we're going to do a few examples of finding smaller sides from a right angle triangle. Okay, so here we are with a few examples of finding smaller sides of a right angle triangle. Okay, the setup is very, very similar to finding the hypotenuse. Again, I'm going to write down my formula of A squared equals C squared minus B squared. Right, in the last type of example, when we were finding the value of the hypotenuse, it was really important to get C squared in the right place, but A and B were interchangeable. Okay, this is exactly how we're going to work this one as well. Alright, A squared has to be the thing that we're looking for. So I'm going to change A squared into X squared. No matter which version of Pythagoras we're working with, our missing value is always on the left-hand side here. C squared has to be the biggest value in my triangle. Okay, that's the one that's opposite the right angle. In this case, we're using the number 65. B squared is whatever other value we have in the triangle. So in this case, we're using 60. Alright, once we have this set up, it's exactly the same as what we were doing in the previous examples, except for instead of adding our two values together, we're going to take away our two values once we've squared them. Okay, so 65 squared is equal to 4,225. Remember, I get that by doing 65 times 65. 60 squared is 3,600. So x squared, when I take one away from the other, is going to give me a value of 625. To undo the squared, what we need to do is square root 625. Which will give me a final answer of x is equal to 25 centimeters. Okay, so the structure is very similar to what we were doing before. Step number one is to enter in the numbers that you've got in your triangle, making sure that you put the biggest one first so that when you take them away, you don't get a negative number. Second step is to square these numbers, so do 65 times 65 for 65 squared, and 60 times 60 for 60 squared. Take those numbers away, and then square root your answer to get your final length of your triangle. Okay, if you need to take a bit more time to copy that down, and then by all means pause the video here. Otherwise, I'm going to move on. Okay, one more example. Again, I'm going to write down my formula first. A squared equals c squared minus b squared. Remember, the longest side is always opposite the right angle, so my longest side is 16 in this case. X squared is equal to 16 squared minus 13 squared. Sixteen squared is 256. Remember, that's 16 times 16. 13 squared is 169. Okay, if I'm taking away those two numbers, 256 take away 169 is equal to 87. Right, already alarm bells are ringing in my head because 87 is not a square number that I know. I don't think it is a square number. Okay, to get my x value, I'm going to do the square root of 87. And right enough, in my calculator, I get a long string of numbers. It's a big long decimal number. So I'm going to just round to 2 decimal places. My answer is 9.33 centimeters to 2 decimal places. Okay, this example is just to show you that sometimes it doesn't work out perfectly, and that's okay. You just need to round your answer as best you can. 2 decimal places tends to be my preferred method, although if you want to do 1 decimal place, that's absolutely fine too, because you're still getting to the nearest millimeter, which is pretty accurate. Okay, again, if you need more time to copy down this example, then pause the video here. If not, we're going to move on. Again, here are 2 scaffolded examples for you to try out. Just the same as before. Remember to get, in this case, your largest number in first. So in this purple triangle, we're using 73 first, and then the other number, 55. This scaffold's not very good because it should have takeaways in there. A bit of editing on the fly, making sure that you've got the right values in. Same with this one. I haven't followed my formula through. There we go. Okay, so complete these 2 examples. Pause the video here just to make sure you don't get the answers, and I'll get you the answers on the next slide. Okay, so here we have our 2 answers. The purple right angle triangle is 48 centimeters, and the green right angle triangle is 65 centimeters for x and y respectively. Right, your final activity for today is to go to the exercise that has been posted in chat for you. You should choose between the red level and the orange level of questions today. The red level deals with one method at a time, looking at finding the hypotenuse first of all, and then finding shorter sides or legs of the right angle triangle. The orange level is more of a mix of questions, so it gets you thinking about which of the 2 methods you've learned today you need to choose. Okay, once you've completed that exercise, make sure you upload whatever you've done to OneNote, and then I will see you in the next lesson. Thanks very much, everybody, and I hope to see you soon.